Today I am gonna talking about exponential function. For exponential function, we should know my base is larger than 0. So I have two type of base. The base is larger than 1 or the base is between 1 and 0. First of all, I have to say for exponential function, base is a constant number and variable appears in the exponent or index. We see always all the variable appears in exponent. So we say it's exponential function. Anyway, we say for base, I have base larger than 1 or base between 0 and 1. If base is larger than 1, I say function grows or increase with x, or when x becomes larger, y goes larger and larger, and for x between 0 and 1, I say my function decay. That means if x becomes larger, my y becomes smaller and smaller. So let's show on the graph. Here we will see when x goes larger, y becomes larger and larger. We will see when x is 0, y is 1, it's my y-intercept, and my horizontal asymptote is y equals 0 here, but never this graph touch x-axis, and my range is from 0 to positive infinity. My domain is from negative infinity to positive infinity. Now I will go for this one to show when x is between 0 and 1. We will see that the function decrease and when x becomes larger. So I say the graph decay. Again, my y-intercept is when my input is 0. So my y-intercept here is 1. And asymptote is y equals 0. My range is from positive 0 to positive infinity, and my domain is from negative infinity to positive infinity. To show transformation, I try to get y equals 2 to the power of x as my initial function and show all the transformation on the graph. Now I want to show if I add up a number after my exponential, in the initial exponential, my function, my graph will be moved up or down. But if this number is positive, we'll move up, and if the number is negative, we'll move down. So I will show on the graph here. We will see here the for this one, 2 to the power of x plus 1, the y-intercept comes up to 3. That means if I put x as 0, we will see here 2 to the power of 0 gives me 1, 1 plus 2 gives me 3. So it will come up 2 units, and my horizontal asymptote would be 2 here, for initial was 0. Exactly, I take this graph and bring it up here, which gives me 2 to the power of x plus 2. How about when here we will see here 2x minus 2, that means I bring this function, I get it and bring it down 2 units. So my asymptote, horizontal asymptote would be y equals -2, and my y-intercept would be -1. So if I add up with a positive number or subtract with a positive number, we will see my initial function, we will go up or down. Now let me make them invisible. Now I want to check when I have coefficient, and my coefficient, the absolute value of my coefficient is larger than 1 or is between 0 and 1. When it's larger than 1, you will see on the graph, I have a vertical stretch. And when this coefficient is between 0 and 1, I have a vertical compression. And how about when my coefficient is negative? When my coefficient is negative, I have a reflect from the x-axis. So I have a reflect from, let me make them invisible. I have a reflect from x-axis. That means my range would be from -infinity to 0. So my range would be from -infinity to 0, and we will see here when a is larger than 1, vertical stretch. When coefficient is between 0 and 1, I have to say vertical compression. Let me make them invisible again. Now I go for exponent and see when x multiply by a number which is between 0 and 1 and a number which is larger than 1. That means coefficient of x is between 0 and 1 and larger than 1. First of all, I make them visible, and we will see my asymptotes, my y-intercept don't change my asymptote and y-intercept. Now I will say if coefficient of x is larger, we will see larger than 1, I have a horizontal compression. We will see here. And when the coefficient of x is between 0 and 1, I have a horizontal stretch. Let me make them invisible. Now I want to check when my exponent subtract or add up with a positive number. When I see x minus 3, x minus k, and this k is larger than 0, I have to say my initial graph will move to the right side exactly k unit. Look here, my initial graph moved to the right side 3 units. 1, 2, 3. Here 1, 2, 3. So y-intercept here would be 1/8. And how about this one? My graph would be moved to the left side, 3 units. 1, 2, 3. So we know all the transformation now, and we say when my exponent subtract with a positive number, I move the graph 3 units to the right, and if add up with a positive number, I move 3 units to the left side.